Here we've got number 10. This is where it kind of all comes together. Calculating the delta H and the delta S we've done before, and then we're going to calculate our delta G. That looks like an N just the way that this is zoomed in here, and that looks like a U just the way it's zoomed in, but that actually, trust me, is a 0 up there. Unfortunately, the values for sodium bicarbonate and sodium carbonate were not in our reference guide. So if you looked those up, a good place for this. I know a lot of teachers poo-poo on Wikipedia. But if you look up a compound on Wikipedia, one of the things that they give you is some thermochemical data, delta S and delta H being two of those. So let's calculate delta H. This is going to be the H of our products minus our H of our reactants. So let's do, let's see, delta H is equal to H prod minus H, sorry, the sum of our H reactants. And if I look those up, I should end up with, let's see, delta H naught negative 1130.77 kilojoules plus negative 393.5 for carbon dioxide kilojoules plus negative, let's see, 285.8 kilojoules. And we're going to subtract from that 2, because there's, in this problem, 2 NaHCO3s times its value of negative 950.9 kilojoules. If I plug all that into a calculator, we should have it spit out for us a delta H value of 91.73 kilojoules. Doing the same thing for our delta S. Delta S is the sum of our S's of our products minus the sum of our delta S's of our reactants. If we plug in those numbers, we're going to end up with 136 joules per Kelvin plus 213 joules per Kelvin plus 69.9 joules per Kelvin. And then we're going to subtract from that 2 times 102 joules per Kelvin. And if I plug that into my calculator, it's going to give me a delta S of 214.9 joules per Kelvin. So now we're going to calculate our delta G. Delta G is equal to delta H minus our temperature in Kelvin times our delta S. Now if you notice, our units of joules are different in delta H and delta S. Delta S is just joules, and H is kilojoules. Our temperature in Kelvin will cancel that Kelvin out, so we need to get our energy units, our joules, in like terms. So I'm going to convert this to kilojoules per Kelvin, and all I need to do is divide that by 1,000 joules, or if we're really going to be specific, do our 1 kilojoule times 2.149. I'm sorry, 214.9 divided by 1,000 joules. Our joules are going to cancel. We're just going to be left with kilojoules. That was a really bad crossbar, but this is going to give us 0.2149 kilojoules per Kelvin. Now, to find our delta G, we're just going to take our 91.73 kilojoules minus our temperature in Kelvin, which was 25 degrees Celsius plus 273, and that's in your review guide or your reference guide, times our 0.2149 kilojoules Kelvin, and that's Kelvin there. So we get our delta G, and our delta G is going to be 27.7 kilojoules. So what this tells us is this is a non-spontaneous reaction. If this is positive, if our delta G is positive, it's non-spontaneous. If it's negative, it is spontaneous. So this combines our two factors that we've learned before.